Now, decimal or base 10, binary or base 2, and hexadecimal base 16 are all positional numeral systems that use a set of symbols or characters to represent numbers. Base 64 is similar in the sense that it deploys a set of 64 symbols to represent values, but it's not really used arithmetically. Rather, it is generally deployed in computer software for encoding binary data. So when we say base 64, we usually mean base 64 encoding. The standard base 64 character set generally consists of the uppercase alphabet, a lowercase alphabet, all the numbers, a plus sign and a /, a total of 64 symbols. Base 64 encoding is the operation of converting data into ASCII text format so that it can be transmitted in a text stream or held in an XML document, for example. Typically, the input is binary data containing non-printable characters, so conversion to ASCII is required before it can be sent as an email attachment, for example. The way base 64 works is by successively taking 3 characters of input and converting them to 4 characters of output. So it increases the size of your data to be stored or transmitted by a third. But this is more efficient than just converting your input to a hexadecimal string, which would double your data size. Although hexifying small amounts of binary data is a perfectly valid thing to do. So let's look at an example. Say we have the word AND in our input. These characters have decimal ASCII values of 65, 110 and 100. In binary we have 3 bytes represented like this. So what we do now is reinterpret these 3 bytes as 4 6-bit segments. Each 6-bit segment can hold a value between 0 and 63, and in this example we have 16, 22, 57 and 36. These values are used to derive the encoded characters that represent our output. So what we need to do now is look up these values on our base 64 index table. Oops. So we look up 16, 22, 57 and 36 and determine that our output characters will be Q, W, 5 and lowercase k. Simple as that. Thus, AND becomes QW5K. The output is a third larger. So what do we do when we reach the end of our input and there's only one character left? Say for example we've got this G left over. Well, we're going to need 2 6-bit segments to accommodate this, which gives us 2 values, 25 and 48, to look up on the base 64 index table. Thus we will output characters Z and lowercase w. And the convention is to pad out the remaining 2 characters with equal signs, so the length of the output is a multiple of 4 bytes. What about if we have 2 characters left over, say G and M? This will require 3 6-bit segments. Again, we consult the base 64 index table to determine the output characters, and we pad it out with an equal sign. So that's how base 64 encoding works. I hope that made some kind of sense. Cheers.